All right, good afternoon. Welcome to the Takeoff Training Checking Units by Week class. I'm Bill Wright, part of the Fremont Takeoff team. So we're going to take a look at how we're checking units by week. We're going to go through what our Swiss looks like and then do the step-by-step process for actually identifying a unit, seeing where it's at on the building, and then going through the whole checking process. So the first thing that we want to do is take a look at the Swiss. So if you go to the standard procedures page on the portal and go to the engineering section, our checking guidelines Swiss is going to contain all of the instructions for how we do our unit check by week. So the Swiss itself looks like this. It's a one-line Swiss. When checking, following these guidelines. So we broke it down, and actually there's a lot of steps. So we set it up in this Word document so we can follow that way. When you look at the Word document itself, it's broken up into several sections. The first part is how we initially set up our processes and work our way through to where we get to the units by week. When we're doing that unit by week portion, it's going to be down here 3 or 4 pages into this document. So it starts out here, works our way through, and what we'll be doing is going through the unit fabrication checklist. Now, I'm not going to have this up on the screen for reference as we're doing this. I'm going to have my own copy off to the side so that I can track through and follow along using my checklist as a guideline. So I'm going to move these out of the way. And I'm going to move this teaser page out of the way as well. So when we're checking units by week, we're developing a folder structure that has the units, and they're listed out by based on the unit tracker, and we're going to be checking those. And what we're going to do is we're going to go to we'll open up the unit based on what's in the folder in our, close these. I was doing it a little advanced training there. So in this case, we're going to be looking at 825 industrial. So I'm going to have my shop drawings open, and I'm going to open up my unit out of the unit check by week folder. So I want to identify where this unit occurs on the building. To do that, I'm recognizing that this is unit U085 that I'm going to be doing the checking process on, and I find it on the key sheets. So if I bring my key sheets up, I'm going to use the search function and look for my U085. This is going to help me identify where this unit occurs, and it'll list every occurrence of the unit. So for example, if I had a typical unit that occurred on multiple elevations, it would list it every single time that it occurred on the elevations. I would base my checking process on where this occurs on that specific week. So in this case, this is a week 6, day 3 unit, and it occurs on the sheet 227. Well, this search feature allows me just to click on that, the search itself, and it'll bring up this unit in this location. So I can see it's on page 227, and it's highlighted, so I can see exactly which unit it is. One of the things that I want to do is be able to visually come back to this unit as many times as I need to as I'm doing this checking process. So I'm just going to put a box around it so I can see where it's at. So my eye is going to track straight back to here. I'm not going to wander around that page wondering which unit am I looking at. So here on my shop drawings, I see that this is on page 227. So I'm going to use the bookmarks, and I'm going to navigate to page 227. And I'll do the same thing. I'm going to identify which unit this is. and I'll put a box around it. And again, that's way, so I've got a visual control so I can keep tracking straight back to that unit. So now that I've got the location, I've got it tracked to my shop drawings, I can move the key sheet out of the way temporarily, and I've got my unit assembly drawing open. Now I'm going to follow the same guidelines that are in the Swiss and go in that same order. So after I've determined where the unit is, I want to determine what type of unit this is. So for example, we might have a sill track or a stack joint happening on one side. There might be a soffit or a parapet. Those are kind of the parameters of the horizontal connections. And then I might have a split mullion, a corner, or a jamb. There may be a transition involved. Those are basically the vertical conditions that I'm going to be looking for. So in order to tell what that is, I'm going to start looking at the shop drawing details. I'm always going to use the same sequence when I'm doing my checking processes. I'm going to start at the bottom of the unit and work my way to the top. And then I'll start vertically from the left side and work my way to the right. So if I look at the bottom of this unit, this is my detail 1 on 603B. So if I navigate to here, I see right away that I've got a sill track. Since it's the bottom of the unit, I know that it's not this lower portion I'm looking at, it's this portion here. And it's attached to a sill track, but I'm seeing that there's something unusual happening here. It's not attached to a curb or stud framing. It's got this offset steel plate. So that's going to prompt some things for me to think about as I'm continuing this process. As I'm looking at a unit, I want to make sure that it's going to work, that it's installable, that it will fit within the framework that we're trying to set it in. So this is a key piece of information for me already, that this is not just a typical detail that's happening here. So I'm going to store that. For now, as I'm looking at what type of unit this is showing me that it is a sill unit, so it's a sill track. Now I can navigate back to my page 227 with the bookmarks, but the weird thing about bookmarks is if you just click on it again, it doesn't take you directly back there. You have to click to a different page, and then you got to click back to the 227. So I'm going to make a shortcut there instead, and I know that this page 227 that I'm working on is page 120. So I'm just going to remember that. I'm going to be visiting this elevation sheet several times during the course of checking my unit. So I'm just going to remember that I'm on page 120. Now when I want to go back to this, I'm just going to type it in. It'll make just going back to that much faster than having to navigate to a bookmark and then go to the real bookmark. As I work my way up the unit, I might take a quick look at the horizontal to see if there's anything here that's going to catch my eye. For example, if there's a horizontal that's got a back pan or something like that. Now, let me see, I'm having a little difficulty here seeing this, so let me try this trick that Pedro showed me yesterday. So my horizontal is typical horizontal. Sometimes there's a panel, sometimes there's spandrel glass. So nothing really catches my eye there. When I go up to the next detail at my upper horizontal, it's the same page, but the 3A, so that just tells me that the condition is a panel instead of glass. Then when I go to my upper detail, the 2 on 606, okay, so this one's going to make me pay attention here. I've got a lot of things happening. So I'm seeing that this is the horizontal I saw in that other detail. It's called out here as my 3A on 501. It's showing that I've got a panel attached here. It's showing what's happening with the top of my unit. This I would consider to be a parapet head because it's not using a stack joint head member. And I've got a bayonet that's going to be used for lifting that unit for hoisting. But a lot of the other things that are happening here, I may need to take into consideration when I'm looking at what's happening with my hook lugs here, or I'm seeing that there's a guardrail that's happening and there's a bunch of panel work. So this is not a typical head condition at a parapet either, because this unit is now out in front of this curb. So all of those things may factor in when I'm actually doing the check on this unit. For now, I'm still identifying what's happening with the unit itself. So far, what I've determined is that it is a sill track at the bottom and a parapet head. So that gives me the guidelines of what type of framing this unit is built out of. When I go back to my elevation, I'll take a look at my vertical details. I've got a 21551. So that's a pretty typical split mullion condition. And then I'll go back to my right side vertical. It's a 21563. So I see I've got a corner, and it's not a 90-degree corner. So let's see what it is. Okay, I've got a 95-degree corner here. However, it says varies. So if something says varies, that's giving me a trigger that it's not always going to be 95 degrees. There might be some corners on the building that are exactly 95, but it's likely that there's some that are not exactly 95. So if that's the case, I need to know what that miter is going to be. That'll come into play, especially as I start looking at how the horizontals are going to be mitered. So I'm going to go back to my elevations for a minute. So what I've done so far is I've just verified kind of the base condition for the unit. If I'm continuing to check on the unit assembly drawing now, I'm going to start looking at all of the detail bubbles. So I'm going to verify the detail bubbles on the shop drawings and make sure that they're actually called out correctly on the shop drawings. So my method for verifying that is once I've looked at something, I'm going to put a green line on it to indicate it's a good visual control that I've actually looked at it and I've verified and I agree that it's showing correctly. So I've already glanced at these details. At this point, what I can do is verify that the one on 603B that I saw at the sill is actually showing up correctly on the unit. The 3 on 501 that I saw in the horizontal, the same thing. Again, as I continue moving up, I'm matching to make sure that they're working the same detail bubbles from the unit assembly drawing all the way up to my unit 21606 on the head. Then I'll do the same thing going across vertically. I've got a 2 on 551 and then the 2 on 563. So I'm seeing that there's something else happening on my unit assembly drawing here, but I'm not seeing a detail bubble happening in this case. So this usually for us indicates that there's a pony tube here, especially because we got the 2.5-inch dimension. It's shown in the hidden lines. It's in that area that would require a pony tube at a corner. So I'm expecting to see a pony tube happening there. So I'm going to investigate this on my shop drawings a little bit. And I can see, because this is a Revit model that's been converted into these shop drawings, I can see that there's a pony tube happening in here. And I can see the mat clips that are happening behind the pony tube. But I'm not seeing a detail for what's happening on the actual detail itself. So that's a little bit of missing information. So that's key. We're going to store that away for later. At this point, I want to take a look at what's the intention for that part. So I know that this T1 is going to be my tube, and I see my part number is my 2124145T. So I'm going to investigate that a little bit. I'm going to see, is that actually the part that we have in the gen notes? So when I go to my parts on the gen notes, I can find that piece here, and it's showing this is the part that matches what my pony tube is on this project. So I'm going to do a search and see where does that pony tube occur. When I bring up the search, type in that part number, it lists out all of the results. So this top result is actually this page. Then I've got 2 more hits here. I've got a 654A and a 654B. So when I click on this, the 654A is going to show me that this is the condition. It's a generic detail, but it's showing how the pony tube is intended to be used, what the parts are, how it's attaching to the mat clip, etc. So I've got this, the 54A and the 54B. They're very similar to each other. What I'm going to do, since this is kind of a generic version of this detail, I'm going to call out that I need to see this detail bubble on this sheet. I want to show that this is this one on 654A. So with that in mind, I'll just mark this up to that 654A, and that'll be my first red line on here because I want to see that detail bubble. It's not showing up now. So I'm going to go back to my elevation. Again, just typing in that page 120, using that visual control to easily navigate back to the specific unit I'm looking at. And now I'm going to start checking. After I've verified all my detail bubbles, I've identified the added one that I want to put in. I'm going to verify the dimensions. So I'm going to look at my horizontal dimension here. I've got, oh, I don't have a horizontal dimension here. Okay, so why would I not have a horizontal dimension at this condition? Well, in this particular building, there's a lot of fish scale walls. So what's happening is each of these floors is offset from the floor above or below it, and they have different layouts based on which floor they're on. So what I do have here, instead of having dimension strings showing up on my elevation, which wouldn't work trying to track down this whole row, you can see that this next row down is way offset from this row here. I actually have the floor plans showing, so I can go to those to determine what's happening. So in this case, this upper floor plan, this is the 5th floor that I'm looking at here, is this 21157. So if I go to that detail, and it looks like my printing features working here. So if I go to my detail 2, I see that I have the split mullion to the corner, and I've got a dimension string, and here's the other key bit of information. So you recall we looked at the detail and it said that this was 95 degrees, but it said varies. So now I'm seeing that I have a 95.79 degree. I'm going to have to use that when I start doing my calculations. So I have a 2 foot 6 3/8 is my dim point to my center line. I want to verify that that's what's showing up on my unit assembly drawing. Once I verify that that's correct, we've already looked at that vertical detail on the left. We can go back to our elevation sheet just for reference here, and we see that that's that split mullion 21551 detail. It's a 2 3/4 inch wide mullion pair, so half of that is 1 3/8. And the way that we see that is our dim point is right at the center line of this 2 3/4 dimension. That's how I'm verifying that this 1 3/8 is correct. Now, when I go back to the detail at the corner, when I have a corner condition, I'm going to do something slightly different on the corner because it's difficult to get a daylight when you have a mitered horizontal and a corner mullion. So the way that we put this information together that works for the shop, it works for Fabs, is we actually show where is the glass in relationship to the daylight of that frame. So in this case, my frame size is my 30 3/8. I do that minus 1 3/8 deduction. That takes me to the daylight. That's what this is indicating here. So I'm showing to daylight so far. And then to the glass, I'm going to do the deduction based on the detail. So then it's minus that extra 1.5 inches. And that takes me to my 27.5 inches. So far, I've verified that I agree with that. I've mathematically calculated to make sure it works. The course of the presentation, I'm actually not using the calculator and doing the math just for demonstration's sake. During the normal course of the unit, I'd actually be calculating these out one by one. So once I verify my dimension strings, oh, I've got another one across here. I have a pony tube showing and I have a dimension 11 3/16, and then it's showing that it's 2.5 inches wide. Okay, well, let's go through this exercise again. If I go to my elevation, I'm not seeing anything specific on here. I do have a floor plan that's 21157. Okay, I've got a 21157. Well, I do see that the embed and the Mac clip is showing here, but I can't tell what it is dimensionally. So at this point, if I'm not sure, I might have to investigate this further. I might have to go to the embed plans. I might have to do some calculations based on how the embeds are spaced. I might have to call the drafter and have them do a live cut for me in Revit and give me a measurement. So the other areas that I could explore, if I go back to my elevation, I can track this back to the floor plan. And on this 227, that's going to occur on this side of the building. This is up on the 5th floor. So in my bookmarks, I'm gonna go to my 105A, and again, I got this problem with the printing thing here. Can't see that sheet. So here, I'm going to look at that connection. And again, it's verifying that my 95.79 degree is correct. But I can't really tell what's happening with the embed here either. So in this case, I'm going to go into CAD. So I have a CAD version that shows my 157, and I knew that I was going to be doing this demo, so I actually penciled in where my tube was going to be. Can't see that too well from here, so I'm going to hide this dimension for now. And what I want to determine is what it is from my daylight to my tube. I just centered the tube inside of the embed, and if the embed is placed properly in the CAD drawing, which it should be based on this being drawn in Revit, then I should be able to just get an aligned dimension and verify, okay, I'm showing that this is an 11 3/16 dimension from my daylight to the side of my tube, and that's what I'm showing in my elevation on my unit drawing. So I'm going to agree that that's correct. If I had any doubts, if the thing looked weird, if I wasn't sure, or I wanted to just verify it, then I would take some additional steps at this point and go down a few tangents before I mark this green. So once I verified all of the horizontal dimensions, I'll do the same thing on the vertical. I'm going to go back to the elevation, look at the vertical dimensions. Now the vertical dimensions are just shown in a long string, so I'll need to go to the details to see where's my dim point and then what's my deduction. So here I've got the dim point is to the top of this panel. I've got 3/4 to the bottom of my sill track. Then I've got from my sill track to the top of the horizontal 3 inches. My unit drawing is showing 2.5 inches, and that's a byproduct of this coming in out of Revit. So I have to understand that the Revit insertion point is usually 7/16 below the bottom of this sill member, and that's based on being able to place the families in correctly. And now when the takeoff program reads that, it's going to give me this dimension, which is based on the Revit insertion point. So I'm going to agree that this 2.5 inch dimension is correct, even though I don't see this anywhere on the actual detail. It's a background that I have to know in order to verify that that works. When I go back to the elevation and I look at the dimension strings, then the rest of these I'm going to be just doing based on the calculation. The 9/11 3/4 is to the top of this horizontal. It tells me here top of horizontal. I go to the detail. It verifies that the dim point is at the top. I do the deduction. The 2.5 inches is how tall that is. Do the deduction for the dim point to the top of the sill member. That gives me my 113.5. In that same fashion, I'm going to go ahead and continue working my way up the unit and getting from this 2'5" top of horizontal to top of horizontal. will equal to my 26.5 daylight. Then when I get to this top detail, I've got a 111.25, and that ties in back into my, it's a 1'11" in this case, and that ties into my 21606 detail. So now when I go to my detail here, I can see my 1'11". My dim point is way up here to the corner of this panel. Then I'll do my deduction to the top of the horizontal and then to the daylight. That'll give my 16.25, my 2.5 inches for the top for that size of that head member. And then my total size, I'll just mathematically add all these up and it'll equal that total size. So at this point, I've verified all of the dimension strings. The next step I'm going to verify is what's happening with the glass. So we have a very specific process for this. It's too time consuming to go into it. I'm going to describe it briefly. We're going to open up the units that were created for the glass release. We're going to find that unit on the glass key sheet in the same spot that this unit's in and verify the glass that we ordered and make sure that those mark numbers match these. The reason we do it that way is the unit mark numbers might be subject to change. If there's something that happened to a unit, let's say an added angle occurred, then the glass mark number needs to be the same, but the unit naming may have changed. So we're going to use that process to verify the glass. In this case, I've done that process already. I agreed that the glass mark number is what we had on the original purchase order, so I'm good with the glass mark numbers. So next up, I'm actually going to start checking the fabs. So we'll take a look at this horizontally. If I go to my sill fab, forgot to erase this from yesterday. Give me a second. So at my sill fab, I'm going to take a look to make sure. Let's go back to our shop drawings for a second. Take a look at our detail 1 on 603B. The part number, W751153, I'm going to verify that. The finish is paint. And then I'm going to make sure that any gaskets that are showing up on our fab ticket, the 304, the 276, all that looks correct. I'm going to look at if there's any notches required, there's any mitering, and then the cut size. So here I have a miter, and my miter is showing me 47.5. When I went to my detail blow up here on my 157, I see that I have a 95.79 degree. So what I'm going to do is bisect that angle to this 47.89 degrees. I'm going to round that to 47.9, and that's different than what we're seeing here. Now, the takeoff program may want to round these, but what we've been doing is rounding to the nearest 1/10 of a degree, even though mathematically the shop says that they can cut to within a half a degree. It's much more accurate for us to be able to do these within a 1/10 of a degree. So I want to see this actually showing up at the 47.9. So I'm going to mark that up as an update that I want to see on this fab ticket. Next, I'm going to check the length of this. If I look at my unit assembly drawing, I'm starting out with a 30 3/8 from my center line to my dim point on the corner. So I'll do my -1 3/8 deduction, but this is a mitered part now. So in order to determine what the deduction is for the miter, in most projects, we go through a prototype unit process. So in the prototype unit, this is 825 industrial. So in the drafting, takeoff, prototype, final fabs, in the layout Joe folder, we have all of the layouts that were created to determine what the deduction is from the DP to the cut size of the parts. So in this case, I'm going to go to that layout. This is my degree. It's that 95-degree corner. These are all the horizontal parts. Now, what I'm seeing here is that when this layout was done, the dimension point was actually 1 inch out past the face of the glass. So that's a little bit farther than what our actual current shop drawing is showing. If I go to my corner detail here and verify what my dim point is showing, 2 on 563, the dim point's actually right at the face of the glass. So that tells me that from the time we did prototypes, these were done off early profiles. The actual shop drawings were set up slightly different. So rather than just finding the number that was stretching over to my intersection on the sill member, I actually need to string that number myself, which I did here. So my deduction is the 2 and 27/32. So as I finish the math on this, I get my 30 and 3/8 minus the 1 and 3/8 minus the 2 and 27/32, and that takes me to this dimension of 26 and 5/32. And I'm seeing here that my cut size is not quite that. So I'm going to mark this up at the 26 and 5/32. When the PE goes in afterwards to do these updates to get the units ready for release by week, if this minor of a deduction is something that cannot mathematically happen in the program, they will bring it up to the PCs. We'll have that discussion together. And if we decide that it's okay to leave the dimension that comes in off the program rather than the one that we mathematically get, then we'll make that decision and we'll mark this up accordingly. However, if this is something that's due to the changing of this degree and just the rounding is achievable, then we'll expect that even though it's only 1/32 of an inch, that we'll make the update so that this part comes to the correct length. So in a similar way, I'm going to look at each of the horizontal parts, working my way up the unit assembly drawing. So I started with my sill. I see there's something I want to fix there, so I'm going to mark it in red so that it can be adjusted later. You'll notice that when I mark a mark number that's linkable, I only go halfway through. If you do a strike through all the way across this, it makes it difficult to actually click on this to open that. So then I would go to my next part, which is showing here, the setting chair. I would go back to the shop drawing detail, verify what's happening. Once I agree with that, I'll mark it up in green and then mark this green as well, and then work my way up. So I'm doing a few shortcuts here, obviously, just for the sake of the presentation. As I work my way up the horizontal, this next horizontal is an intermediate. I'll do the same thing with the math. I'm going to mark this up. I'm going to mark up the cut length, but I'm going to verify everything else as well. I'm going to make sure that my gaskets are showing correctly, that it's the right part number, that the finish is showing, so that all of that is verified as we go.
Hey, Bill.
So when I go back to, let me change that. I don't want to split here.
Bill, can you hear me?
Now when I go up to my next horizontal, I've got the horizontal that has the pony tube attached on the top of it. So let's take a look at that on the shop drawings to make sure that that makes sense.
Hey, Bill.
When I go to this detail, this is going to be my 3A on 501. Well, I have the horizontal cut here, but I'm not seeing what's happening on that pony tube again. So if I want to reference that, the pony tube specifically, I need to go back to see what's happening on that 565A detail that we had penciled in previously. So if I go to back to my one second here, 654A, I can see what's happening with my pony tube. It's 2.5 inches wide. It's flush with the back of the vertical. It's got the hook lug on it, and it's got angle attachments that are attached with this 13 FP fastener. So all of that's critical information. I'm going to be looking at every single one of these details, at every single occurrence of the fastener, the size of the part, all of the small details are going to be considered. So somebody's typing my name up here.
Can you hear us, Bill?
Just trying to get my attention.
Bill, can you?
Chris, did you have anybody posting to you?
Yeah, can you hear me?
Hey,
Let's
Bill,
move
can you hear
on.
us?
Bill,
Bill.
can you hear us?
So here we have the pony tube showing on top of the horizontal. So in addition to doing all of these, can't hear me.
Bill.
Hey, Bill.
My speaker was turned off. What's up?
Hey, so Bill, Yana had a comment about the standard face of system when prototypes are done.
Okay. Yana, you have something? Well, my speaker turns off if it's not being used for a long time. So that's what happened. That's why I couldn't hear you.
No, I'm sorry. I didn't mean to interrupt. I just commented that prototypes, it's not changed from prototypes to the job. Prototypes are always done with the standard face of the system, which is 2 1/4. And whenever you look at prototypes, regardless what you have on the job, it will be standard face of the system. So you probably, some cases, you will not have it matched.
Okay. Duly noted. And that's why we don't just go directly off of the layout that we see. We have to verify what's happening very specifically with the shop drawings. So we always go back to the shop drawings for our reference. Okay, so that's a good point. If somebody could erase the graffiti on my screen, please. All right, so as I'm looking at my pony tube here, I'm seeing that it's got some hole prep for my angle attachment. So I'm going to go back to that detail. I'm going to verify that the hole spacing is correct. Here I've got a dimension for at the DP, so I'm going to verify that my 11 3/16 plus my 2.5 inches gets me to the right side of this pony tube. It's going to give me that 13 11/16. I'll verify that. I'm going to make sure that my angle clip itself, when I look at the pony tube fab, this one, I'm going to look at the actual clips here that's being used to attach. I'm going to check the spacing on here. This tube is 4 inches long with a 1/2 inch from each side. That tells me that the spacing is 3 inches between them. When I go back to my horizontal, can somebody erase this, please? This is distracting for me.
Chris said he can't erase it.
Okay. So when I get to here, that dim point plus the 13/16 is going to be to the center of the hole. Then I've got my spacing between the holes at the 3 inches. So all of that's going to be verified one by one by one. As I do each of these, I'm going to cross them off that they're green, and I'll verify this. So I'm going to shortcut a lot of that just in the nature of the presentation and go back to the unit assembly drawing. So at this point, I've looked all the way up through this top horizontal. Then we'll take a look at what's happening at the head. So at the head member, again, we go back to our shop drawing details over here. That 2 on 606, I've got an open head member. So that's going to give me the layout for the pony tube inside of there. Dimensionally, it's going to be the same, but I have a smaller clip because now that clip has to actually fit on the other side of this screw port, which is why you saw when we looked at this tube, it had a notch up at the top and it's got a much shorter angle. So we'll look at that angle, see what the spacing is, verify that on my horizontal part, make sure that these all match, because we're going to put pilot holes on there when the shop goes to assemble these. They're just going to run the screws in under the pilot holes and they've got the tube positioned where they need it. I'm seeing that there's a gasket 276. I'll verify that. Now this is not showing on this detail, but I have a blow up of what's happening here on this 1 on 606A. So I'll go to that, set this page up so that I can see it. Thanks, Pedro, for that tip from yesterday. Now when I go to here, I'll see the remainder of what's happening on that detail. It's got an angle clip attached so that I've got a panel attachment. So I want to see that my angle is showing up here. It's got my flush is shown. This is one of my standard call outs. So as I'm doing these, I'm going to be marking these off that I agree with those. I've got the 276 gasket. I've looked at the part number, 3165. It's got that painted finish. And that size, I'm going to mark up with the correct size. I'm going to clean up this miter angle, etc. I'm going to look at which fasteners are being called to attach this. Again, I don't have that thing with the attachment. So it's hard for me to verify which screws are being used if I don't have that detail at this cut. So this is calling for these flathead undercut drill flexes. So I may have to go on a few tangents here to make sure that this is the fastener that I want to use in this condition. So if that's the case, I may have to come back to this in a second. So for now, we're going to assume that I've done some additional investigations and I'm happy with this, and we'll mark that green as well. Now, as I'm going finishing up that head member, I see that I have a couple of head fillers here. So I'm going to look, I've got one that's a straight cut, and I've got one that's got a miter and a notch on it. Well, in this case, this looks a little weird to me because this is not the standard logic of what I'm expecting to see. This part will be hard to snap in if it's got a miter and a notch on the same piece. So I'm actually going to mathematically change this. I don't want to see this with the notch on this end. I'm going to cross this off. I only want the miter on here. So I'm going to check that miter degree. I'll adjust the length as necessary. I'm going to do all the calculations to make this work. But then on the other head member now, in this particular case, I need to do a notch on the one end. And I'll make sure that it's on the correct end, notch the right side. And I'll have to call out specifically that I want this one and only this one to have that notch on it. So I'll recognize what my mark numbers are here. So on this 255, I'm going to put a note on here to notch this end as shown. I'll put some extra dimensions there. Again, I don't have time to write all of these down, but I'm going to make those notes, and then we'll have that discussion if necessary when this goes back for updates, okay? So after that, we're going to start looking at what's happening on the verticals. So vertically, if I go back to my elevations, I see that I have a wind load condition at the sill, and I've got a dead load condition above. Well, I've looked at my horizontal details, so I recognize that my dead load is going to be on this hook lug. We already talked about how the pony tube is set up. So when I get to the pony tube, I'll be able to do some verifications there as well. So now I'm going to look at what's happening for the vertical at the bottom. My split vertical, for example, I've got the 1 and 15/16 notch at the bottom, and that should be the notch that I'm expecting to see on the wind load sill condition. So that's a typical wind load sill. I'll mark all of those. I may mark them up one by one. However, if these have been vetted through prototype units and it's a typical condition, this notch should be pretty standard, and I shouldn't have to measure every single portion of this dimension. If I've had this handoff meeting, which is part of that checklist meeting from the very beginning, and we verified that this has already been approved as the correct size of the notch. If this hasn't been approved by the time I get to it, I'm going to verify every single dimension to make sure that this is the real wind load notch that I want to use here. So again, I'm going to verify my part numbers by going back to my elevation. You see that I'm navigating back to these shop drawing details multiple times as I'm doing this process. This is standard for us that we revisit these details many times. So as I'm going through here, it's my 5263, verifying that, and it's a painted finish. I've looked earlier, we've looked at the pre-takeoff meeting notes. I know that there's not multiple finishes on this project, so I don't have to worry about that part of it. It's just, if it says paint, then it's just a painted part. As I go into the horizontal heights, I'll check each height from the bottom, working my way to the top. I'll make sure that each of the pictures is showing up correctly, and then I'll verify those in the chart. And again, this is just for shortcut's sake. I will have already verified all of those. When I go to the hook lug height here, I want to make sure that I mathematically determine that that hook lug is in the right spot. So as I see my 21606 detail, I see where my hook lug is, and then I have a lot of dimensions. So I need to do some calculations to see where this thing really is occurring. I've got a dim point that occurs way over here, and I've got some dimension strings over here. So I really need to see, where's my dim point? What does that track to? This is my 6th level here. Are there some deductions there? So yes, that's 1.5 below the dim point. Then from there, I can go from that point down to this surface. Then I can go from here up to get to the top of this hook lug. This is the top of the mat clip rather. And then I got the deduction from the top of the mat clip to the top of the hook lug. Now, it would be helpful if this shows me a specific dimension. If not, I might open CAD to verify what that is. We do have a kind of a standard that we use. So it's usually 3/4 from the top of the mat clip to the top of the hook lug. But I'm not going to take that for granted. I'm going to do as much digging as it needs in order to make sure that this is exactly right. Once I've verified all of those, I'll double check the height of this. I'll make sure that my gaskets are showing up properly. Again, I'll see these on my vertical detail. It's showing that I have an access hole required in here. That's so that I have the ability to get the horizontal screws in through this web of the actual mullion. So I'll mark that off. I've got a hook lug and it's showing attached, and I've got a bayonet. So I do have a bayonet showing. I have other conditions on this job where I have a lifting lug instead, so I've got to look for that on those other types of units. So I'll be looking at these. Then double checking my size and my bayonet layout. Once I've verified all of those, then I'll move on to the corner vertical. The corner vert is here. I'm going to look using those same guidelines. Now here I have in the chart my horizontal heights. I've already looked at the horizontal heights based on this vertical mullion, so I might use this as a shortcut to make sure all my horizontal heights on my other vertical look correct. And you'll notice that I don't have a hook lug showing up on the corner vertical, and that's because the hook lug is actually on the pony tube instead. So when I look at the pony tube fab, I'm going to verify that that's in the right location and that it's aligned with the vertical that's on that same unit. Once I check my parts here, I've got a bayonet happening here. I've got my layouts and my gaskets. And again, I'm shortcutting, but that's all going to be based on what I'm seeing on my vertical details and going through each of the dimension strings and going through all of the horizontal cuts as well. So I'll be flipping back and forth through these as many times as necessary. Now you can see that when this goes to assemble this screw in here on this male corner vertical, it actually hits that male leg a little bit. So the detail doesn't call this out, but I know that I need an access hole there, otherwise they won't be able to get that screw in. So I'm expecting to see that same note, 11/16 access hole. But I'm not seeing that here. So that's one of the things that I want to add in. Now, that's a typical note for us. I'm not going to call it out in the same amount of detail. I'm just going to call out 11/16 hole and just go ... If the PE has any questions about that when they start doing those updates, we'll have that discussion. They'll go, what's this? But for us, it's something that occurs occasionally, so they know that if they see a note like that, that they have to apply that very specific drill 11/16 access hole. It's this exact note, drill 11/16 access holes as required. So basically it's just copying that note over. Now, there is a tool here that I could use. I could use this little capture and take a snap of this and try to paste it. But sometimes in Bluebeam, if you have these little gaskets here, they want to be on the same layer or something. So this is usually too close. And if I try to paste that note, it's going to want to paste what's on that gasket layer. So that's why I don't frequently do that. I'll just write that note on there instead. So that takes care of the corner vertical. Then I'll go to, this is actually red because it's got a problem with it. Then I'll look at the corner trim, verify the length of that. It's actually the same length as the vertical. I'll use the horizontal cuts to make sure that that makes sense of where the corner trim needs to go. Then on the pony tube, I'm going to make sure that the angles are working. We already looked at these when we were looking at how they attach to the head and the horizontal member. And I'll verify these clips. I'll mark those up. Then I've got the height here. So in this case, I've got a 7¼ inch dimension. Well, if I look at my vertical here, I can take the total, the difference between the top of the hook lug, the 154 and 5/16, to where the next horizontal is, which is where that pony tube's going to go. So picture the pony tube fits inside of this area. So I really want from the top of this horizontal to the top of this to match. So I'm just going to make this deduction, this 154 and 5/16 minus the 147 and 1/16, and that's going to give me the 7¼ that I'm expecting for my pony tube height. I'll verify all of the other things here and finish checking that unit. So as I finish those, I'll look to see if there's other notes on here. There's a gasket showing on the bottom. I want to see if there's any gaskets that are showing on the unit assembly drawing. I want to see, are there added notes that the shop needs? Do we need to give them an index on how parts are adjusted next to each other? So I'm going to look at this in even more detail. What we've reviewed so far is just mathematically checking. But in addition to that, I want to, as I'm going through my shop drawings, I'm thinking about how is this unit going to be installed? Will it fit into that opening? Does that deck edge that's occurring up at that parapet near the roof have some impact in being able to get this unit into that position? Will it fit there? Do I have the right miters? So all of these things are going to come into question as I'm making these checking decisions as I go. So you can see that this is a very precise and very logical approach that we take to doing these, and that the quality that we're building in to doing this checking process is going to build in what's happening, not only going to the shop floor, but also going out to the field. The less defects that come out of our process, then the smoother everything else is going to go, which is why we take the time and invest in doing a good quality control check for every unit, for every week, for every project. So as we're doing this process, just recognize that when we do have questions that come up, we want to have these discussions so that if something looks unusual, we can resolve this before it gets to the stage where it gets out to the shop floor and they see some kind of an error that they have to deal with.
Hey, Bill, we had a question from Yana. She wanted to know how much when it comes to the shop drawings, how much you're leaning on those and how much you trust them versus how much you question what's in the detail.
So we have to use quality shop drawings to make sure that we're producing a quality product. So because the PCs have this experience level, when we see something that looks unusual, we don't hesitate to follow up on it. So we're not going to just look at the drawing and say, that's what it's mathematically telling me, I'm going to trust it. What we do is we look at something and we analyze it. if we do some analysis and we think that there's something that needs to be questioned or adjusted, we will definitely ask those questions and get that dialogue going. Okay, so just I'm open for any other discussions. We have just a couple of minutes left, but as of now, I'm open for any additional items.
Bill, there was another one that just came in from Steve. He said, do we question things that should be standard? For instance, at the head condition, the angle should be field use. At least that is our standard. How would that get brought back to drafting?
So if we see things that we are recognizing should go in a certain way, which as the PCs, we're involved with every project from all the different drafting team. We know what we should see consistently. If we see something that we think is a standard, we've got it documented in other places that's a particular way that we do that, is we'll mark that on the shop drawings first, then we'll also add that to our drafting feedback board, and we'll create that feedback loop. Now, as we're making forward progress, we want to try to develop these feedback loops earlier in our process so that they don't make it into completed shop drawings.
And Bill, just one more thing on that head condition. So, you know, you were questioning that notch around the pony tube, right? But in that condition, it seems like you wouldn't need that head filler at all, right? So I was just curious about that too. Do you ever go back and just say, well, we don't need a filler here anyway? Like that filler isn't required for anything. It's behind a panel. It's a pony tube there anyway. Like, you know, so we ever just remove the filler and not even tell drafting, or do you just always go by what's on the drawing?
No, we wouldn't do that because it's in the material takeoffs at this point. And by the time we get to Fabs, we don't want to make adjustments like that that would throw off the amount of materials that we're using, that we're expecting there. However, if we saw that this might be an improvement that we could make for the future, this is something that we could put on the drafting feedback board as a possible improvement for future use. We wouldn't do it on this job-to-job scenario. We're in production work by the time we're here. We're way beyond deciding on if this is a good idea or not. We have to do the production work.
Okay, just curious about that. Thank you.
Just to speak on that, there was a couple of instances where I think on one particular job we did remove it. I forgot the reason why, but we made the decision to just remove it from the filler because it's not visible. So just to speak on that a little bit. I think it was O Street or something.
Yeah, I mean, we should be catching all that in the drawing reviews. Like, it's not really your job to do that, but I just was curious how you guys see it when you get there. You know, because you guys have good eyes when you're getting into this stuff. And you show me that one detail, I might catch something like that. You show me a giant set of shop drawings, and I'll probably just miss everything. So.
There was a time when Dave Morales was working with us that he said to keep those in there. So I've been kind of going for that same. If they're shown in the drawings, keep them in there because structurally they're helping the head, which I thought was kind of odd. But they said because that head channel is a channel, that popping that thing in there helps it structurally to hold it together. So he always said keep them in there even if they're not visible. So I don't know if that's something that we've changed since then, but.
No, I mean, this detail right here, you can get rid of that gasket, you can get rid of that filler, and you can take that angle and make it field use. Make everybody's life easy because you know they gotta take that angle off just to put the membrane in. You can't put the membrane in the way it's shown, so there's a big problem.
And then we've also heard from the PM saying that angle should be on, just don't cock it, let the field pull it off. That way it's there, the holes are lined up.
Yeah, we already made that decision that we just make those out of break shapes when we buy the panels. If you go out on this detail a little bit, look at the right side, you know, there's an angle over there that is got to be installed anyway, so you might as well just do them both, you know.
Okay, any additional questions on the unit check by week?
Really, yeah, I would say, Bill, the one thing for me is just like, it's so great to see how much detail you go into. So this was a great class for me just to see that you know, that attention to detail on everything. It's really, really fascinating. It was a great class, I thought.
Yana had another question. She asked, how much do you look at the ACAD unit assembly drawing BIM? Do you look at the Revit model?
So for our checking process, we don't need to go into the Revit model. I might look at the BIM 360 version of it if I want to see the context of how something is being used. So for example, if I had any concerns about will this unit be able to be installed, or are there adjacent things that I should be aware of as I'm doing this, then I might look at the BIM 360 model of it. But I'm not using Revit to do any checking part of the process. So if I have a question, that one we were talking about earlier of where is this pony tube on this unit? If I can't tell what that is, I might reach out for help and ask the drafting team to help me look at that to see, does this make sense where I have it, or can you give me a more specific information? And then as far as the BIM of the unit, if you're opening the unit itself in CAD, in most cases, I don't do that. My validation of units is from a different frame of mind than it is from building the unit. So I really want to mathematically prove that this unit is absolutely correct. And I'm going to use the shop drawings and a calculator for the most part to determine that. If I have to rely on using the BIM of the unit, then that's almost just making sure that what you built doesn't have any clashes and all of that. But realistically, I need to prove that mathematically and not visually. Okay, good questions. Any others? That's about it. Okay. Well, thank you for attending the presentation. I'll get this recording posted to YouTube by tomorrow so that if anyone missed it, they can go back and explore it later.
Good job, Bill.
Thank you
Thanks,
very
Bill.
much, guys.
Thanks, Bill.
Thank you, Bill. It was intense.
Thank
Yeah,
you, Bill.
very fast paced. I had to skip over all the math.